Right at the start, let me tell you that in the explanation of this solution, I have used concepts which I have covered in my earlier videos on electrostatics. The videos were formula and important points, class 1, class 2 and class 3. This particular problem is based on the formula that I covered in the class 1. So if you haven't watched that video yet, first watch that video, then come back to this video. Otherwise, you may not understand or you may not get the link of what I am saying. Okay? So now let's start. The question says there are two equal positive charges. When you read the question, always give proper attention to each and every word. Question says two equal positive charges. So say plus Q and again plus Q. Equal positive charges. Then it says another charge is placed right at the middle of the line joining these two charges. So that means if this is X, this is also X. So this is the midpoint. And it's given in the question the third charge is Q. So instead of naming the point, let me name it as Q. Now the question says these three charges should be in equilibrium. And for that, what is the condition? There are four options as usual. Now let's proceed. These are point charges. They have to be in equilibrium. That means net force on them has to be 0. So force on point charge, which formula? Coulomb's law, point 1 of our class 1 video. Right? So what was Coulomb's law? F equal to K Q1 Q2 by R square and R cap. Right? So this way we should think for this question, which should be the formula. Okay, now this is a formula, easy formula. Next, let's consider this charge Q. Say it is positive charge. Then this is positive, so this will repel it in this direction. Right? This will also repel it in this direction. Now what will be the magnitudes? Say in both cases, for both these forces, this will be capital Q, this is small q, the distance is x, so the magnitudes will be the same. Very simple. So that means this charge will remain in equilibrium. Right? So if this is positive charge, this will remain in equilibrium. Let's consider if this charge is negative charge. What happens if this is negative charge? Now this is positive, this is negative, so this will attract. This is positive, this is negative, so this will attract. The directions are opposite, but the magnitudes will be the same. So net force on Q will be 0. So that means this will be in equilibrium, that particular charge. Right? That means considering only this charge, we cannot come to any conclusion what should be the relation between Q and capital Q. Right? So let's consider, say, this charge. It has to be in equilibrium. So what are the forces on it? So this charge is plus Q, this is small q. So the force on this due to small q charge will be, by Coulomb's law, this one. Now this charge will also experience a force due to this charge. How much will that be? K into Q divided by 2x square, because the distance will be now x plus x, 2x square. Now if we add both these forces, it has to be 0, because this charge should be in equilibrium. It will only be in equilibrium when the net force on it is 0, and net force means force due to this plus force due to this. Now if you solve it, K cancel out, Q, 1 q cancels out. From here, we will get q by x square equal to, if I transfer it there, minus capital Q by 4x square. So x square cancels out. So what we get? Q is equal to minus capital Q by 4. And that is option A. So the correct option for this question is A. Right? Say in this question, we used a very simple formula, Coulomb's law, but we had to use the concept of equilibrium, which we had learned in class 11. So usually what happens, if there is a question on Coulomb's law, they will mix it with some other concepts of some other chapter, maybe of class 12, maybe of class 11. In many cases, the other concept is usually equilibrium. That's why your concept of equilibrium has to be very clear. If your concept of equilibrium is not clear, you watch my video on equilibrium, which I have already uploaded in my channel.